Hello everyone, my name is Aranya Biswas. Welcome to my channel Vlogging with Aranya. Today I am going to teach you what is number system. Now number system basically is the technique to represent and work with numbers. Numbers can be represented in various forms, in various digits like 1, 0, 0, 1, 0, 1, 0. This represents a specific number. 97 is a number. A number can also be represented by variables such as A, capital A, B, etc. etc. Now, this number system is divided into 1, 2, 3, 4 parts. Decimal, which we basically use. Binary, which the computers understand. Not only computer, any machine, our Android phones, or even any cell phone understands binary language. Octal and hexadecimal. Now, each of these 4 number systems has a base. What is a base? A base is the number which represents the total numbers in that number system used to represent a number or a digit or something. Decimal number system consists of 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. We have 10 digits. So decimal number base will be automatically 10. Binary. As the term binary suggests, it suggests 2. It consists of 2 numbers, only 0 and 1. Computer doesn't understand other than any of these 2 numbers. Computer, Android phones or cell phones don't understand other than these 2 numbers. As they are binary digits, 0 and 1, or binary suggests 2, automatically its base will be 2. Octal. In octal we have 8 digits. 0, 1, 2, 3, 4, 5, 6, 7, which has base as 8. So 1, 2, 3, 4, 5, 6, 7, 8. Then we come to hexadecimal. Hexadecimal consists of 11 digits representing numbers, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 digits. Also, the double digit numbers like 10, 11, 12, 13, 14, 15 are represented by A, B, C, D, E, F respectively. I repeat, in hexadecimal numbers, the double digit numbers are represented by A, B, C, D, E, F, and it goes on as the alphabetical order and as the numerical order. 10 is represented by A, 11 by B, 12 by C, 13 by D, 14 by E, 15 by F, 16. So automatically 16 will be represented by G, and it goes on and on. Therefore, its base is normally 16, we say, as it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. So its base is 16. Now, we can convert decimal to binary, that is, from one number system to another number system by following certain methods. First, we learn the decimal to binary conversion. Any number written in this format is considered as a decimal number. 17 bracket 10 is a decimal number. Now, any number written in this format 1 0 1 0 1 1 0 1 brackets 2 at the base, this is represented as binary number. As it has only the digits which a binary number system must contain, that is 1 0 1 0 1 1 0 1, only 1 and zeros. So its base is 2. Any number in this format is a binary number. Any number with the base 16 is an hexadecimal number. Any number with the base 8 is considered as an octal number, and this goes on. Now let us learn the decimal to binary conversion. So how will we convert? The given number, which is decimal number, the given number has to be divided by 2 and the remainder has to be written at its side. So 17, which is divided by 2, will obviously give us a remainder which is 1. As 17 is an odd number, it won't go with 2. So if 2 8s are 16, 17 minus 16 is 1. We write the remainder at the beside. 8 goes with 2. So 2 4s are 8. No remainder, that means 0. We write 0 in the beside. 4 goes with 2. So 2 2s are 4. No remainder, 0. 2 again goes with 2. 2 1s are 2. No remainder, 0. 1 does not go with 2. So 2 0. That will give us 1. Now, how will we arrange this? This has been given as last to first. That is from 1 to this one to this one. So this will give us 1 0 0 0 1 brackets with the base 2. Never forget to give this base. Now you may ask why we are dividing with 2. Because since the the binary number system base is 2. That is why. Now we'll do the vice versa also. That is from binary to decimal. Suppose let us take the same number, that is 1 0 0 0 1 at the base 2 will give us what in decimal numbers. So let us see how are we going to convert this. We are going to write serially 1 0 0 0 1. So here's what we will do. We'll multiply each of the digits with 2 with the power from 1 starting from 0, 1, 2, 3 respectively. I'll show you how. 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus again 0 into 2 to the power 2 plus 0 into 2 to the power 3. So 1 and 3 zeros done. Then plus 1 into 2 to the power 4. Let us see if the answer comes 17 to the power 17 base 10. Any number to the power 0 is 1, as we all know. If you don't know, then take this knowledge. So 1 into 1 is 1 plus 2 into 0 is 0 plus 2 into 2, 4 into 0 is again 0 plus 2 into 2, 4 into 2, 8 into 0 is again 0 plus 2 into 2, 4, 4 2s are 8, 8 2s are 16. Let us just justify if we have done miscalculation. 2 into 2 into 2 into 2, 1, 2, 3, 4, since power is 4, 2 2s are 4, 2 2s are 4, 4 2s are 8, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16. So 16, 2 to the power 4 is 16, into 1 is 16. Therefore zeros, nothing. 16 plus 1 is 17. Therefore the answer is correct with the base 10. So here is how we convert from binary to decimal, and before that from decimal to binary. I hope you have understood this. Let's move to the next part, that is octal. But before that, I would like you all to see this sum also. How to convert from decimal to binary in case of a number with points, or a number with a decimal point. So we have the number here 37.45 base 10 will give us how much to the base 2. So we'll solve 37 and 45 individually. We'll solve both the numbers individually. Once 37 and then we'll do 45. So 37 again solved with 2 divided by 2. 2 18s are 36, remainder goes 1. 2 9s are 18s, remainder goes 0. 2 4s are 8, remainder goes 1. 2 2s are 4, remainder goes 0. 2 1s are 2, remainder goes 0. 2 zeros are 0, remainder goes 1. Okay. As we have learned earlier, we'll follow the bottom up approach. So 37 to the power 10, as we have done individually, first only 37 to the power 10 will give us 1,0,0,1,0,1, as we have got 1,0,0,1,0,1 base 2. Now, how will we find the number 45? That we will do by multiplying 0.45 into 2. 0.45 here means 0, nothing. So 45 into 2 we know 90. We have a point here, so 0.90. Integer is 0. This side, which is integer 0. The fraction part we write here this has to be done in a table format separately. Multiplication, integer part and fraction part. In a point number, this is the fraction part, this is the integer part, as you all know. So 90 we get 0.90. Then we'll again multiply 0.90 into 2. That is, we get 1.80. Let us multiply 0.90 into 2. 2 9s 18, 1, 8, 200 plus 1 point sits after 2 places, so 1.80. 1.80 we get, so we have the integer part as 1, we write here integer part, and we have the fraction part as 80, we write in the fraction part. Again we multiply this by 80. 0.80 into 2 will give us 1.60. We'll write the fraction part over here in the fraction part and the integer part over here, that is 1. Again we multiply 0.60 into 2, that is we get 1.20. We write the integer part here 1, we write the fraction part here 0.20. So this way we also get the binary form of the fraction part in the main sum. This way, this has to be done in a table. In this we'll follow the top down approach, that is from 0 to 1. Now one thing to note is here that this will continue, so it's better we give a dot 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 here. If we again multiply 0.20 into 2, it will give us 4.0 or something, or 1.40, no matter, whatever it gives, but approx will do at least till 4 or lesser than that. It's not necessary to do more than that. So the binary part of 37.45 base 10 is 100.011 base 2. We of course need to write approx, since this will continue. The fraction part of this will continue, so we have obviously need to write approx. As we have got the 37 binary form, this one, and the 0.45 binary form, this one. So this is how we convert decimal to binary in case we have a point digit. I hope that is clear to all. Now let us do the decimal to octal, or after that hexadecimal. Now as we know, octal has base 8. So let us take a number 37 to the base 10. Now as we have done in during decimal to binary, we since the binary base is 2, we always divided with 2. Here also, since octal base is 8, we will divide the number with 8. I hope that is clear to all. So here we have the number 37 to the base 10. So 37 will be divided with 8. So 8 fours is 32. 8 fours are 32. 37 minus 32 gives us 5. Then 8 zeros are 0. It will give us 4 only. Again we'll follow the bottom up approach. So for 4 and 4, 5. So 37 to the power 10 in decimal will give us 45 to the power, sorry, not power, 37 to the base 10 will give us 45 to the base 8. This is in case of a normal number, that is from decimal to octal. Now let us see a number with points, which will be converted from decimal to octal. So as we learned in this decimal to binary, we'll divide the first, that is the integer part, with 2. Here also we'll divide the integer part with 8. Since octal base is 8, binary base is 2, octal base is 8. So we better remember it. So we divide 37 by 8, that is 8 4s are 32. 37 minus 32 gives us 5. 8 zeros is 0. 4 minus 0 is 4 as usual. So 4, 5, bottom up approach. So 37 to the power 10, that is the integer part of this whole number, gives us 45 to the base 8. Not power, sorry, again mistaken. 45 to the base 8. Now let us work with the fraction part. As in the decimal to binary, we multiplied the fraction part with 2, that is 0.45 into 2 gives us whatever, 0.90. Here we will multiply with 8, that is the fraction part 0.45 into 8. 0.45 into 8, that gives us 3.60. The 3 is the integer part. We write 3 over here in the integer section. 0.60 is in the fraction part. Again the same. 0.60, always multiply the fraction part with the base. 0.60 into 8 is equal to 4.80. 4 in the integer part, 80 in the fraction part. 0.80. Again 0.80 into 8, that is 6.40. 6 in the integer part, 0.40 in the fraction part. This will go on as usual, continue as usual, so we give a dot dot dot. So 45 to the base 10 in decimal will give us 346. 346 will follow the top down approach. 346 to the base 8. Now as we have done here, we just wrote it together, the binary number of the integer part of the decimal number and the binary part of the fractional number, that is 40.45. we wrote both of them together with a point. Here we will do the same, that is 37.45 to the power to the base 10. 37 we got, that is 45 to the power 8. So we write 45 to base 10, we got 346 base 8, so we write 45.346 to the base 8. Of course we will write again approx, since this goes on continuing. Now with the same number, that is 37 as we used earlier, with the same number let us convert 37 base 10, that is in decimal, to a hexadecimal that will have the base 16. We'll follow the same process. 37 divided by 16, 16 to the 32 will give us 5 as the remainder. 0 will 16 divided by 2 divided by 16 will give us 16, 0 will give us remainder 2. Remainder in the side. Again we'll follow the bottom up approach, 2 to 5. So that is 37 to the power 37 base 10 will give us 37 base 10 is equal to 25 base 16. I hope that is clear. Till now we learned from decimal to octal or hexadecimal. We converted decimal to octal, decimal to hexadecimal. Now let us convert octal to decimal. So we have a number here that is 645 to the base 8. Now we have to find it out that how much it will be when it will be converted to a decimal number, which will have the base 10. So the process is that we have to multiply, we have to go this side during the multiplication, or rather calculation. That is, first we have 5, so we will start with 5 into, since base is 8, 8 to the power 0 plus next 4 into, we have done 8 to the power 0, now we will do 8 to the power 1 plus 6 into, we did 1, now we will do 8 to the power 2. Let's calculate. So 6 into 8 to the power 2, 8 is 64. 64 into 6, we have 384. So 384 plus 8 to the power 1 is 8 only. 4 is 32 plus anything to the power 0 is always 1. So 5 into 1 is 5 equals, so we'll add up, that is 384 plus 32, 5 plus, therefore it comes 421. Therefore 421 to the base 10. Okay, so here is how we convert an octal number to a decimal number. Okay, so now we are going to convert hexadecimal to decimal. Now let us take an hexadecimal number, that is 2A5. Now, as we all know, as explained in the first part of the video, that A represents 10 with the sequence, that is A is equal to 10, B is equal to 11, C is equal to 12, and so on. So 2A5 to the base 16, since hexadecimal base is 16. Now how much will it give when it will be converted to a decimal number, which will have the base 10 as usual. So therefore, as we did this conversion, we multiplied each of the numbers with 8. Here we will multiply each of the numbers with 16, following the same rule. So first we have 5, that is 5 into 16 to the power 0 plus A represents 10, so therefore we will write 10 into 16 to the power 1 plus next 2 into 16 to the power 2. So 16 square, 16 into 16 is 256. 256 into 2s are 512. Plus 16 into 10 is 160. Plus anything to the power 0 is 1. So it's 5. We'll add up. So 5121160. So it gives the answer 677. 677 to the base 10. So this is how we convert a hexadecimal to a decimal. Okay, so goodbye guys. The video ends here only. If you like this video, please like it, share it, and subscribe my channel. And please comment. Please do comment in the comment box. I've kept it open. Please comment how it was. If it was informative, please say it was informative, so that I can bring its next part that will do more calculations, including binary to octal, hexadecimal to octal, octal to hexadecimal, and binary to hexadecimal, which will be coming in the next video. Till then, goodbye, and let us revise what we had learned today. We learned decimal to binary, decimal to binary, binary to decimal, octal to decimal and vice versa, hexadecimal to decimal and vice versa. So we learned these today. Hope you enjoyed this video. Hope this was informative for you all. Thank you. See you in the next video.